Okay, so in the last few classes, I did uh, all of uh, all of this, right? So I did composition of matter, atomic structure, periodic table, and today I'm going to finish chemical bonds. And I think we'll finish all of IMAT chemistry in around 3-4 weeks. So like till next month, we'll be done with end of August, we'll be done with chemistry. So in this chapter, you'll learn all about bonds, the different kinds of bonds elements can form, and so polarity, electronegativity, all of the things related to bonds you learn in this chapter. So uh, let's start with intermolecular forces versus intramolecular forces. Now, for intermolecular forces, right, there are uh, these intermolecular forces are called dipole-dipole forces or London dispersion forces. So temporary bonds are called intramolecular forces, and the bonds that are permanent, like covalent, ionic, metallic bond, that are called intermolecular. So covalent, ionic, metallic bonding, all of this is intermolecular, and the temporary bonding is called intramolecular. So you need to know the differences between inter and intramolecular forces. So intermolecular forces, right, are the forces that hold molecules in a substance, whereas intramolecular forces are the forces that hold atoms in a molecule. So intramolecular forces are the forces between atoms, and intermolecular forces are the forces that hold molecules in a substance. So uh, in a substance instead of an atom. Now, intermolecular forces, right? Intramolecular forces are weaker than intramolecular forces. So intermolecular is weaker, whereas the intramolecular forces are stronger. Now, uh, intermolecular forces, right? Intramolecular forces, they determine the state of matter, solid, liquid, gases, and their physical properties such as melting point and boiling point. So, intramolecular forces, the temporary forces, will determine whether or not you will have a high melting point or a boiling point. Whereas the forces like ionic, uh, covalent, and metallic, all of this will determine the chemical behavior of a substance. So these the temporary forces are attractive forces, whereas these intramolecular forces are chemical bonds. And they are categorized again into covalent, ionic, and metallic bonding. So all of this is called intramolecular. All of this, the temporary, is called intermolecular. Right. So let's start with the first intramolecular force, that is called ionic bonding. So what is ionic bonding? It happens mostly in metals and non-metals. Electrons are lost in ionic bonding. Metals will lose electrons to form positive ions. So when metals lose electron to non-metals, metals will form positive ions called cations. Remember, positive ion are cations and negative ones are called anions. The negative ions are called anions. Non-metals will gain that electron to form a negative ion or an anion. So ionic bonding will happen in metals and non-metals. This is mostly the case. And ionic bonding is very strong as the force of attraction between the positive metal and negative non-metal is high. So metals, right? Metals will lose electrons to non-metals. So the metals will give their electrons to non-metals, and non-metals will gain that electron. So when metal loses an electron, it will form a positive ion. Non-metals will form a negative ion. Now, this negative and positive attraction causes ionic bonding to be very strong. So this is why ionic bonding is very strong. And ionic bonding is formed when electrons are transferred from metal to non-metal. the compound is held together by electrostatic attraction. So this attraction between the positive and negative ion, right, are called electrostatic attraction. So this was pretty much ionic bonding. I'll get to ionic bonding later on, but let's go move on to covalent bonding now. What is covalent bonding? Covalent bonding mostly happen between non-metals. And covalent bonding is the strong electrostatic attraction between a shared pair of electron and the nuclei of the bonding atom. So when I have two non-metals, right? This is mostly between non-metals. Covalent bonding is mostly between non-metals. So when two non-metals, they come together, the positive protons and the electrons are shared between these two non-metals, and the nuclei, they fuse together and they will have positive and negative attraction. So between the electrostatic attraction between a shared pair of electron and the nuclei of the bonding atoms will cause covalent bonding. So this is an example of covalent bonding. So these are two different atoms, right? So this is one atom and this is the other atom. Now, the positive charge of this atom at the left will attract the electrons from the of the right side. So electrons of the right side is attracted by the positive charge of the left side. And this will happen the same on the right side. So the right side, the nucleus of the right side will attract the electrons from the left atom. This will cause covalent bonding. And covalent bonding again occurs in nonmetals mostly. So this was covalent bonding. Now, for you to understand more about covalent bonding, you need to know how to draw different covalent bonds. So for example, CO2, right? Is it a covalent bond or an ionic bond? Since these two are non-metals, carbon and oxygen are gases, this will be a covalent bond. And how will this look like? So when I have one atom, that will be my central atom. So when I have one atom, that is called the central atom. And carbon, how will I know what bonds will this look like? Carbon has 4 electrons in the outer shell. How do I know this? Because carbon is in group 4 of the periodic table. So group 4 elements will have 4 electrons in the outer shell. Group 5 will have 5 electrons, 6 will have 6 electrons, and so on. And the reason this is another interesting point. The reason that the last group, or group 0, right, have are not so group 0 elements, right, are not reactive at all because they have 8 electrons in the outermost shell. They are in group 8 and they have 8 electrons in the outer shell, so they are inert. So this is another reason why group 0 elements do not react at all. So where was I? CO2, right? Carbon has 4 electrons. Oxygen, there is 2 oxygen molecules in CO2. Oxygen has, it's in which group? Wait a minute. Oxygen, I think it's in group 6. Yeah, it's in group 6. So oxygen will have 6 electrons in its outer shell. So I'll draw 1, 2, 3, 4, and then I can draw the 5th and the 6th electron with the carbon. So carbon has 4 electrons. 2 of them will be shared with this oxygen, and 2 of them will be shared with this oxygen. And this oxygen has 6 electrons as well. 6 electrons in the outer shell, both oxygens. So I'll draw 2 electrons here, 2 electrons here, 2 electrons here. So 1, 2, 3, 4, 5, 6. This is 6 oxygen electrons. And then 2 of the electrons are shared by the carbon atom. So in total, oxygen will now have 1, 2, 3, 4, 5, 6, plus the 2 electrons from the carbon atom. So the right oxygen will have 8 electrons. Whereas this side, 1, 2, 3, 4, 5, 6, and plus the 2 electrons from the carbon. So this will also have 8 electrons. And when you form covalent bonds, right, the outer atoms or the elements will have 8 electrons in its outermost shell. So when 8 electrons are complete, you have a complete shell, because remember, most elements in the periodic table can hold 8 electrons. There is a condition, I'll get to that, but remember this point, 8 electrons will form a complete shell. Sharing 2 each will make them double bonded. Yes. So when, let's say I have 2 atoms, right? And let's say that this side, right? Let's say that element A gives 2 electrons to element B, and element B will give 2 electrons as well. So let me draw X's for this element B. So when I have 4 electrons in a covalent bond, that's called a double bond. So carbon to carbon double bond, this carbon gives 2 electrons, the left carbon gives 2 electron, the right one also gives 2 electron. So this is a double bond. Similarly, when carbon will form triple bond, this is very rare, but when it does, I'm just giving an example. This left side of the carbon will give 3 electrons, the right side will give 3 electrons. So I have a triple bond right here, like this. And yeah, so in a covalent bond, the outer atoms will form 8 electrons in its outermost shell. Now, there is one condition to this. Period 3 elements like sulfur, chlorine, and aluminum can exceed the 8 electron shell limit. So period 3 elements they can form more than 8 electrons. So for example, oxygen, I think oxygen is in period 2, if I'm not wrong. Correct me if I'm wrong, but oxygen, I think it's in period 2. It can hold a maximum of 8 electrons. So oxygen can hold a maximum of 1, 2, 3, 4, 5, 6, 7, 8. 4, 6, 8. Yeah, 8 electrons maximum. But sulfur can hold more than 8 electrons. So sulfur, right, can hold more than 8 electrons. It can hold a maximum of 18 electrons. So sulfur, aluminum, chlorine, all of the elements in period 3 can hold more than 8 electrons. So when period 3 elements, they form covalent bonds, they can hold more than 8 electrons. You won't need to draw the covalent bond thing in the exam. You don't need to draw the dot and cross diagram. You just need to know this rule, that period 3 elements will form more than 8 electrons in its outer shell. So when period 3 elements are the central atom, they will form more electrons, more than 8 electrons. For example, SF6, sulfur hexafluoride, right? Sulfur hexafluoride is sulfur bonded to 6 fluorine atoms. And you can see sulfur here has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Sulfur has 12 electrons. It can form more than 8 electrons. Yeah, that's the rule that you need to know. So elements outside period 3 want 8 electrons in the outer shell, or a noble gas configuration. What do I mean by noble gas configuration? All of the group 0 elements, right? Group 0, like helium or argon, have 8 electrons in its outermost shell. So this is the case for most elements. Most elements want 8 electrons in their outermost shell because that's the most stable condition. Because noble gas has 8 electrons in its outer shell, it's the most stable. They won't react very much. And the last point in covalent bond is that when making a covalent bond, make sure both the sides, left and right, have 8 electrons. What do I mean by this? Right here, you can see that the left oxygen has 8 electrons, the right one also has 8 electrons. So the outer atoms, the left and the right, or up and down, not in this case, must have 8 electrons in its outermost shell. And again, the only condition is if it's period 3 elements, it can have more than 8 electrons. Yeah, that's covalent bonding. Now, another type of covalent bonding is called dative bonding. So dative bonding is a form of covalent bond. And what is dative bonding? In dative bonding, a lone pair of electron is donated to another atom. So for example, A will donate a lone pair to B. What do I mean by this? Well, let's say I have NH3, right? NH3, and I reacted with a proton. What is a proton? It's a hydrogen that has 0 electrons in its outermost shell. So normally hydrogen exists as 2, where hydrogen will have 1 electron in its outermost shell. So hydrogen, right, it wants 2 electrons in its outermost shell. So a proton is a hydrogen atom with no electron. Because it has a positive charge, the electron is lost somewhere. So it won't have this positive, it won't have an electron. So when NH3 would react with a proton, right, NH3 has a lone pair. NH3, I think it's in group number 5. It's in group number 5. So nitrogen will have 5 electrons. Nitrogen is in group number 5. It will have 5 electrons. So NH3 will have a lone pair, right? Lone pair is basically electrons that can form covalent bonds. Now, this lone pair would be donated to this hydrogen right here. So instead of nitrogen giving 1 electron to hydrogen, nitrogen will now give 2 electrons to hydrogen. And you will get this, this compound where this hydrogen right here will form a bond with nitrogen. And you can see that this is the hydrogen that had no electrons initially, but now the nitrogen will give 2 electrons to hydrogen and you will get a dative bond. So what is the explanation of this? Again, NH3 has 8 electrons in its outer shell, 3 from hydrogen, 3 from these 3 hydrogens, 3 from H3, and 5 from the nitrogen atom. It has 2 electrons that are not bonded at all. They are called lone pairs. Lone pairs are electrons that are not bonded to anything. A hydrogen ion, which has no electrons, can bond with the lone pair of electron to form NH4+. The arrow is structured, the arrow in the structure will tell you who donated the electron pair. So in the exam, when you see this arrow, that basically means it's a dative bond. And the arrow points to the atom that you gave the lone pair to. So in this case, nitrogen gave lone pair to hydrogen. So the arrow would look something like this. This is dative bonding. There's not a lot you need to know about dative bonding. And yeah, so there is one more type of bonding, the intramolecular bonding. It's called metallic bonding. And metals, right? In a metal, you have positive metal ions, cations, which are in a fixed state that is called lattice. And these cations, right, are surrounded by delocalized electrons. The strong electrostatic attraction between positive metal ions and negative electrons hold the metal together. So when positive metal ions form bonds with delocalized electrons, it's called metallic bonding. And these are the 4 types of intramolecular forces you need to know. Now, moving on to intermolecular forces, the weaker forces, or the temporary forces. For this, you first have to know polarity. So let's start with electronegativity. Electronegativity is the measure of the ability of an atom to pull shared pair of electrons towards itself. So what is electronegativity? It's the ability of an atom to pull electrons. And in the periodic table, right, the electronegativity would increase as you move up. And it would also increase when you move towards the right. So electronegativity increases something like this, right? So for example, hydrogen has more is more electronegative than this right here. And fluorine is more electronegative than lithium or sodium, right? So this is electronegativity. And remember, fluorine is the most electronegative element. Why? Because it's at the most right and the most up. So when it's the first element, so that means it will have the highest electronegativity, and it's also towards the right, so it will also have more electronegativity. Now, fluorine, the electronegativity of fluorine is 4. Oxygen is 3.5, and nitrogen is 3. Chlorine is 3. So when two similar atoms form bonds, the electrons are in center because both have the same electronegativity, and thus it will be symmetrical. So when two same atoms, for example, F2 or fluorine, basically when fluorine forms a bond, right? When fluorine forms a bond, this will be symmetrical because both have the same electronegativity. So the electrons that are shared between fluorine would be at the center, So like this. So electrons are towards fluorine. In this case, when I form HF or hydrogen fluoride, electrons would be towards the fluorine. So fluorine, because it's more electronegative than hydrogen, right? So fluorine would pull the electrons towards itself. So in a hydrogen fluorine bond, the electrons would be closer to the fluorine compared to the hydrogen. And because of this, the molecule would become polar. What is polar? When you have an electronegative element pulling electrons towards itself, you have a polar molecule. And when do you have a non-polar molecule? When you have for example, two hydrogen bonds, right? Both have similar electronegativity, so the electrons would be at the center. When something is very symmetrical, in this case, this is a very symmetric molecule, this will be called non-polar. Now, this is the electronegativity of the most popular elements. So it's better if you memorize this. For example, fluorine has electronegativity of 4. If you go down, the electronegativity decreases. So iodine will have 2.5. And if you move towards the left, it would decrease as well. So beryllium has 1.5, lithium has 1, right? So remember these 4 electronegativity: fluorine, oxygen, nitrogen, chlorine, and carbon. So the least electronegative element, right, is in this case, in these 5 elements, it's carbon. Carbon is the least electronegative. So I have a few bonds right here. All of these are polar. Why is it polar? Because I have 2 different molecules with 2 different electronegativity. Hydrogen has an electronegativity of 2, whereas oxygen has electronegativity of 3.5. So the difference between the electronegativity will cause polarity. So oxygen is more electronegative. It pulls the electrons towards itself. So this causes it to become polar. Similarly, hydrogen and chlorine is more electronegative. You can see chlorine is 3, whereas hydrogen is 2. So chlorine pulls electrons, and this becomes a polar molecule. Now, when do you have a non-polar molecule? Again, let's say you have boron and BF3, basically. BF3 is when in BF3, right, a molecule has same elements and same charge. So I have boron bonded to 3 fluorine atoms. 3 fluorine atoms. In this case, right, they are symmetrical. So you can see when I form the line of symmetry, you will see that this is a symmetrical molecule. And because of this, this will become a non-polar molecule. Now, when outer elements like this, fluorine is outer elements, and boron is the central atom in this case, or the central element. And when the outer elements will have the same charge, then you can cancel these 3 charges. Why is that? Well, because boron, right? Fluorine, I told you, is the most electronegative element. So electron negativity, because of high electronegativity, fluorine will take the electrons of boron. So the electrons will move something like this. Because of it moving outwards and it having the same charges, this will cancel out. So if a molecule has same elements and same charge, they are symmetrical and they cancel out. And because of this, they become non-polar. If corner atoms are not the same, corner atoms or the outer atoms, meaning fluorine in this case, if they are not the same, then it becomes polar. Instead of fluorine, if instead of one fluorine, I had two fluorines and one oxygen. So instead of three fluorines like this, I had two fluorines and one oxygen. In this case now, fluorine will take the electrons and oxygen, in case of boron, right? Oxygen is more electronegative than boron. And because of that, oxygen will take its electrons. And because of this high electronegativity, fluorine atoms are more electronegative. They will take more electrons compared to oxygen. Because of this difference, this will become a polar molecule. So in summary, polar molecules are non-symmetric, or they don't have similar corner atoms, and non-polar molecules have similar electronegativity, so they are non-polar. Now, moving on to intermolecular forces, or now comes the weaker forces. Someone has a question. What about NH3? I remember it was polar, right? So NH3 is nitrogen bonded to three hydrogens, right? It's three hydrogens. And nitrogen is, NH3 is polar. Why is it polar? Because nitrogen has a lone pair. So because of this lone pair at the center, right, around these hydrogens, the lone pair will make it polar. So which is more electronegative, nitrogen or hydrogen? Nitrogen is 3, hydrogen is 2. So nitrogen will take the electrons towards itself, pull electrons towards itself. But because of this electron right here, the charge difference would be different. So because there is this charge right here, these lone pair will put a negative charge on nitrogen, more negative, it becomes more negative, and therefore it becomes polar. This is not a symmetric molecule. Because of this lone pairs, you will have a non-symmetric molecule. Yes, it's non-symmetrical. So when you have lone pairs, right, the molecule becomes non-symmetric. Why is that? Because this lone pair will repel hydrogen atoms, because hydrogen will have electron, and these electrons will have a repulsion. This phenomenon is called as Vesper. You don't need to know what Vesper is. Just know that if a lone pair is present, it would become non-symmetric, right? So moving on, intermolecular forces are the forces which are weaker than the intramolecular or covalent bonding. So less energy is needed to break these intermolecular forces. So intermolecular forces need less energy to be broken. And these types of forces are called induced forces or temporary forces or instant forces. Why is this force caused? So because electrons in an atom can push away electrons in another atom to form charges. These charges are temporary since electrons are constantly moving. So I have one atom has electrons at the left at one instant, and this electron has electrons right here. So will there be repulsion or not? There would be repulsion, but this repulsion would be weaker. So in another instant, this electron will come here, right here. So now the repulsion is much more. So this will cause more repulsion. This will be less repulsion. So the molecules would be closer at this point when the electron is far away. So this is called induced forces. You don't really need to know how it's caused. You just need to know that they are weaker compared to intramolecular forces. So atom 1 pushes electrons of atom 2 away since it's repelling, right? Since electrons left at the left would repel the electrons at the right, this will cause repulsion. And since electrons are moving away, there would be a force. This force is known as induced forces. Yeah. So what is an example of this? And remember, induced forces or intermolecular forces will cause an effect on the boiling point of an element. So the boiling point depends on the intermolecular forces, or basically the induced forces. This has multiple names: induced forces, van der Waals forces, temporary forces, all of that. So in this question, which one has a greater boiling point, HCl or fluorine? Now, fluorine is non-polar, whereas HCl is polar. Non-polar will have temporary forces, which means the energy required to break the bonds in fluorine is less. For F2, therefore, F2 will have lower boiling point compared to HCl. Remember that polarity is caused by intermolecular forces. So when an element is non-polar, there won't be a lot of repulsion, because one atom, the electrons are shared between electrons. Whereas when you have a polar molecule, the electrons would be shared towards chlorine. So chlorine would become very negative. Hydrogen would become positive because it's losing electrons. So at this point, it would be very polar, and therefore it will have high melting point or boiling point compared to fluorine. So again, polar molecules have greater boiling point compared to non-polar molecules. Ignore this diagram. It's in A levels. You don't need to know this. Moving on to hydrogen bonding. Hydrogen bonding is another form of intermolecular bonding. So this is another intermolecular bonding. Hydrogen bonding is 5% of covalent bonding. So hydrogen bonding is weaker compared to covalent bonding. I told you earlier, intermolecular forces are weak compared to intramolecular forces. So hydrogen bonding is weaker compared to covalent bonding. So what are the conditions of hydrogen bonding? For you to form hydrogen bonding, hydrogen must be bonded to either of these three elements. So hydrogen must be bonded to either nitrogen, oxygen, or fluorine. So if these three bonds happen, then you have hydrogen bonding. And hydrogen bonding will have the largest boiling point compared to all of the other intermolecular forces. So the temporary forces will have weaker boiling point compared to hydrogen bonding. One point that you need to remember is that in intermolecular forces, hydrogen bonding is the strongest, whereas temporary forces are weaker compared to hydrogen bonding. So in intermolecular forces, hydrogen bonding has the highest boiling point. So hydrogen bonding will increase the solubility of that compound. Why? Because when two elements, they form polar bonds, because remember, in these three elements, there is big electronegativity difference. You can see fluorine is the most electronegative. Fluorine will take the electrons, they will form polar ions. And when you have hydrogen bonding, it will dissolve in water, because hydrogen will now form bonds with water, H2O. So another point, hydrogen bonding will increase the solubility in water of that compound. So now moving on to bonding lattices. Can we complete this? There are 4 types of bonding that you need to know. So you have ionic lattices. Ionic lattices will have ionic bonding. You have covalent lattices. Covalent lattices will have covalent bonding. There are 2 types of covalent lattices, the simple molecular and the macromolecular. I'll explain more about this, but moving on, you also have metallic lattices, ionic, covalent lattices, and metallic lattices. In total, there are 4 types of lattices: ionic, simple molecular, macromolecular, and metallic. So you only need to know the summary of the 4 lattices. So in metallic lattices, metallic or ionic, metallic, where you have positive ions in a sea of electrons, the melting point of metallic lattices will be high. Conductivity in solids is good. Conductivity in liquids is also good. Simple molecular will have low melting point. Conductivity is poor. Conductivity in liquids is also poor. Macromolecular have high melting point. They have poor conductivity in both solids and liquids. And ionic bonding has high melting point because of the attractive forces between positive and negative ions. So positive and negative ions causes high melting point. And the conductivity in solids is poor, but in liquids it's good. So conductivity depends on the movement of electrons. So if electrons are able to move freely, this will cause good conductivity. So in liquids, electrons can move more freely because they have more space. So that will cause more better conductivity. So remember, learn this table. You can take a screenshot. Other than that, you can also take a screenshot of this. This is basically the summary of what you just learned. Take a screenshot of this if you want. I explained everything above. This is just a summary. I hope you took a screenshot. And you also need to take a screenshot of this. And what else? Yeah, I have a question right here. So is there anything else? There isn't. So this is pretty much bonding. So there is this question. Solve it in, I don't think there is only 1 minute left. So solve this question. If you can't solve it, I'll solve it on the Discord. I'll send it on the server. Right. So yeah, this is chemical bonding. In the next class, I'll start chapter number 5, which is stoichiometry. It's all the calculation part, and that's very important because around a lot of questions come from stoichiometry every year. All right, so solve this question. I'll send it on the server. Bye.